Hi everyone, we are going to go ahead and talk about Lab 3. So Lab 3 has three different parts to it. We're looking at part 1 first, and we're going to be exploring directions of force, acceleration, and velocity. So in this first portion, you are looking at a turbine glider, and let me go ahead and press play. Okay, so we notice a few things about this, and I'm not going to go through all of them, but I just want to mention, or maybe throw out there, the idea of what direction you think the force is being applied. So what direction is there a force, and therefore an acceleration? What direction is the acceleration? And so forth. So that is mainly what this first portion is going to be asking about. Then it'll ask about graphs. So what graph represents this situation? Okay. And that might be a little bit tricky to think about at first, but we want to first ask ourselves, is this a varying force? Does it vary with time? Or is that force constant throughout? Okay, so once you figure that out, that'll make this a lot simpler. Okay, and then from there, you can find out, is it moving in a positive direction, or is the force in a positive direction, or is it in a negative direction? And that'll give you your next hint. Okay, and same thing with your acceleration, ask those same questions. Think about how force and acceleration are related. Okay, then you want to answer a question about the velocity versus time graph. So what would that graph look like? Okay, we want to remember that our acceleration is the derivative of velocity with respect to time. Okay, so if you keep that in mind, that should give you major hints to this question as well. Okay, then let me see in here. After those questions, there is a claim that is made by a student, and so you can go ahead and read that and respond to that claim. Okay, then we go to part 2. So let's go ahead and go to part 2 in our lab. So this is lab 3, part 2, and we're looking at a modified Atwood's machine. Okay, so let me go ahead and show you, just going to click a random one as an example, press play to show you what's going on here. So we have some mass and it's connected by a ribbon. The ribbon is being cut, and this is connected to a string with some mass hanging. Okay, so there's a few different components, and this is one continuous system. Okay. So, don't need to watch it for that long, but you want to take some data from this. But first, you need to design an experiment. So you're going to design an experiment to determine a relationship between acceleration of the system and the force that's being applied to the system. Okay, so you can put down what quantity you'll vary, what you'll measure, what quantities you'll hold constant, what you want to calculate, and so forth. Okay, then from there you will collect all of that data, create a graph, and then analyze your graph. Okay, so think about what you would want to write down in terms of figuring out the force that's being applied as well as the acceleration. Okay, of this object. So the force that's being applied is caused by this mass, right? So this is going to be a gravitational force. So you want to connect those in an equation. You can use like a free body diagram to write down an equation for this. Okay, so that's that. Then you want to compare what you found in your graph to Newton's second law of motion, where F equals ma. Okay, so then From that, you can say what the physical significance of the slope is. All right. After that experiment is done, you'll do one more experiment, and that one is to discover a relationship between acceleration and mass of a system. Okay, so go ahead and design another experiment, collect your data, create a graph, and write down what relationship you found. Okay, and that's it for the second part. So let's go to the third part and the final part. Okay, this one is looking at a toy car investigation. So it gives you a little bit of an intro, and then let me go ahead and press play. So this is one of those toy cars that you can pull back and then they like spring forward. Okay, they drive away from you. Okay, and so you want to answer a few questions talking about acceleration and force. It also asks about some graphs, position versus time graphs, how it should look, and about linearizing your graph. So basically what would be a line, okay, and velocity versus time graph, how that should look like, and then what type of graph you should use, or you decide, what type of graph will you use to decide whether the spring in your toy exerts a constant force? So describe what your graph would look like if the force was constant. What type of graph would that be? And so that goes back to that first part in your lab, and that should help you out here. Okay, so that is lab 3, not too difficult. Well, I shouldn't say that, but not too long, I guess I would say. Okay, the taking down data is probably going to be, and designing an experiment will be the longest parts of this lab, but once you get through that, it should be okay. And if you have any questions, feel free to let me know.